Good evening, friends. Today we are discussing the another new topic that is from the cardiovascular drugs. We have further previously discussed the two syntheses for cardiovascular drugs, that is amyl nitrate and diltiazem, or we can say cardiazem. Today we will discuss the another new drug, that is atenolol. The another name for atenolol, that is tenormin. In your university exam, they may be asked like write the synthesis of atenolol or discuss the synthesis and their mode of action for tenormin. Both are same. Both the questions are same. Framing. Uh, it is a subclass for anti-hypertensive drugs and anti-anginal drug. Anginal, that means heart disease related drug, we can say. Anti-hypertensive drug, that means the person which having hypertension every day. So this type of drug we are giving. This drug is also known as beta blocker. It blocks this receptor present on the heart. This effect lowers the heart rate, blood pressure, and the strain on the heart. It is used in long-term treatment of hypertension. It is useful in arrhythmic drug as a arrhythmic drug, that is also known as, or we can say arrhythmic word, it is come from generally arrhythmic drug, we can say like an arrhythmia or irregular heartbeat, we can say, that is in our body. It is a particular problem with the rate or rhythm of your heartbeat. Rhythm or rate of your heartbeat, that is known as anti-arrhythmic drug or arrhythmia, or we can say irregular heartbeat. We can say as irregular heartbeat. Irregular heartbeat. Or we can say a problem with the related of with the rate or rhythm of your heartbeat. It is useful in anti-chest pain drug. So any drug you have right in your exam, first of all you have to mention some key points, how it can be correlated or in which classification it belongs, like atenolol or tenormin. It is in the antihypertensive drug, or we can say anti-aginal drug. So, and their mode of action you have to write in your exam. So first of all, we discuss the synthesis of atenolol or tenormin. So the starting material for atenolol or tenormin, that is para-hydroxyphenyl acetamide. So here this is a para position with respect to acetamide. This is meta, this is ortho. It is known as ipso position, directly attached with the carbon, ipso position, or ipso substituent, we can say. Acetamide, that is, it contained an amide group with having two carbon atoms, acetamide. CONH2, generally CONH2 is known as amide. So here two carbons are there, CH2, CONH2, that means acetamide. Para positions OH group is there, so we can say para-hydroxyphenyl acetamide, para-hydroxy, here it is a phenyl acetamide, this portion CH2 CONH2 known as acetamide. It reacts with generally epoxy chloride, or we can say epichlorohydrin. Epoxy chloride is also known as epichlorohydrin. So epoxy chloride that we actually know the three-member ring with containing oxygen is known as epoxy, right? So epoxy chloride, so CH2 and here is Cl. So this hydroxyl from the H and epoxy chloride here is chlorine. So elimination of HCl takes place minus HCl in the presence of pyridine. So here H and Cl will be removed like this. Here I am just mentioning HCl remove. Here O is here oxygen is directly attached with the CH2 CH CH2O. As you can see, CH2 CH CH2 and O and CH2CO CH2CO NH2 acetamide is as it is, as you are saying, as it is CH2CO NH2. The next step is it is treated with 2-amino propane. 2-amino propane. That means first of all you have to write the 3-carbon. Propane itself says it having 3 carbon and 2-amino propane. That means second number carbon it having amino group NH2. So 2-amino propane. Fill the valency of carbon as hydrogen. Here H. Here H. So 2-amino propane. So what we are getting here is here from the NH2, one hydrogen is left out and this three-member ring is broken down into two. So here the three-member ring is broken down. So here hydrolysis takes place. Hydrolysis takes place. That means addition of water molecules. So here OH and here H molecule is added. So from this side here OH is added because the three-member ring will break. So here OH will be converted and here this bond will be break and on this side CH2O already present, so H will be there from the hydrolysis OH. So from this OH, CH2OH, OH and this H will be removed as H2O minus H2O. So here O, CH2, CHOH, CH2, CHOH, CH2, NH, CH3, CH3. Or simply, I'm just writing over here. What we are doing here is, first of all, in hydrolysis, we have to add water molecule. So, first of all, is this three-member ring will break. This three-member will ring will break. So here OH is attached. OH molecule is added. Yeah, I am showing here OH. This OH both are same. And on this side, H will be there. So H2O, so H plus and OH minus. Okay. So this bond will shift like this. So Here negative charge will be created on oxygen. So that's why here hydrogen will be attached OH as, and here OH minus, because it carrying positive charge. So that means OH will attack on this carbon. So basically OCH2 CHOH is as it is. And then after CH2 NH CH3 CH3. So this OH and this H, these two amino propane from the amino group, here H will be eliminated from the NH2, and here after hydrolysis OH will be there. So OH and H, so both are combined, we'll get H2O. So minus H2O will bring rise here the CH2 CHOH, then after CH2 this CH2, and here NH, this will be attached NH CH3 CH3. So you will get atenolol. So here is a brief discussion for the synthesis for atenolol, or you can say tenormin. It is as a antihypertensive drug, or you can say anti-anginal drug. We are discussing the mode of actions and their synthesis in detail. So if you are in examination, if you are asking the synthesis of tenormin, so you have to write the synthesis of atenolol, both are same. So thank you so much friends for listening me. If you are like this content, then please like to my video and subscribe to my channel, and please share to your needy friends. Thank you so much.